All right, ready for a quick refresher on vectors? In this explainer, we're going to fly through a high-level review of Chapter 2. Think of it as making sure all the key ideas are locked in before we move on. So let's kick things off with a big question this chapter really answers. When something's moving, right, it's not enough to just know how fast it's going. You've got to know where it's headed. So how in the world do we describe both of those things at the same time? And the answer, of course, is with vectors. They're the special mathematical tool built for exactly this job. So let's pull everything together and make sure that foundation is rock solid for all the physics that's coming your way. And you really can't overstate how important they are. I love this quote from the source material. It just nails it. Vectors aren't some side topic. They are literally the language we use to write the story of the physical world. Okay, first things first, let's make sure we're all speaking the same language. This part is all about the must-know vocabulary from this chapter. So here's our first batch of key terms. We're not going to read every single one, but this is your chance to hit pause and really soak them in. You'll want to pay special attention to words like commutative and associative. Think of them as the basic rules for adding vectors. They tell us that, hey, the order and grouping don't matter. And on to the next set. Now we're getting into some heavy hitters, like magnitude, which is just a fancy word for the length or size of the vector, and dot product, which is one of the two main ways we can multiply vectors. Again, feel free to pause and get familiar with these. Moving right along to our third list, what's great here is how it really drives home the difference between a scalar, just a number with a unit like 75 degrees, and a full-blown vector. You'll also spot terms for the polar coordinate system, which is another super useful way to think about a vector's direction and length. And here is our last vocabulary slide. A couple of really important ones here. Unit vector. This little guy is crucial for just pointing in a direction without worrying about length. And vector product, which you'll also hear called the cross product. Okay, so that's the language. All right, with the language down, let's get into the toolkit. We've got the words, now let's look at the grammar, the actual equations we use to work with vectors. These are the formulas you absolutely need to know from Chapter 2. This first group of equations, this is the bedrock. It's the absolute basics of vector algebra. You can see the rules for how to add them, how to multiply them by a simple number, and how we write them out in component form using those unit vectors we just talked about. These are the building blocks. And here's where things get really cool, because you can see how the geometry starts talking to the algebra. See that equation for magnitude? That's just the Pythagorean theorem. And finding the direction angle? That's good old trigonometry. Then we take it all and expand from a flat 2D plane into full 3D space. Now we're building on that foundation. This shows us how to find the total result of a whole bunch of vectors just by adding up their individual components. That's a crazy powerful shortcut. And then, down at the bottom, we get our first real look at the scalar product, or the dot product. This is how we multiply two vectors and end up with just a single number. And to finish off our toolkit, check this out. You can really see the difference between the two types of products. Notice how the scalar product uses cosine, but the magnitude of the vector product uses sine. That's a huge clue. And look at that anti-commutative property for the cross product. It means if you flip the order of A and B, you have to flip the sign of the answer. With cross products, order really, really matters. So, we've got the language, we've got the tools. Now for the fun part. Let's put it all together and look at the big picture for Chapter 2. This is where we connect all those definitions and equations to the core ideas and see why they're so important. First up, Section 2.1. This is where it all begins, laying down the fundamental difference between scalars and vectors. Honestly, everything else in the chapter is built on this one idea. So what's the bottom line here? It's pretty simple, really. A scalar is just a number, like temperature. But a vector has a number and a direction, like velocity. We draw them as arrows, and we have specific rules for how to add them together or stretch them out. This is the absolute foundation. Next up, Section 2.2, which is all about how we take this idea of an arrow and describe it in a way that's actually useful for doing math using coordinate systems. And this, right here, is where vectors become a superpower. By breaking a vector down into its components, kind of like its shadow on the x-axis and y-axis, we can solve really complicated problems. It's a total game changer, turning messy geometry into clean, straightforward algebra. And that leads us perfectly into Section 2.3, the algebra of vectors. This section is all about why we even bother with components in the first place. The main takeaway here is all about precision and power. Look, drawing vectors is awesome for getting a feel for a problem. But doing the math with components, that's exact. In physics, precision is everything. This is a tool you are going to use over and over and over again. And that brings us to the final piece of the puzzle, section 2.4. This is where we learn the two completely different ways that vectors can be multiplied together. And trust me, this isn't just some weird math thing. It describes two totally different kinds of physical interactions. You absolutely have to get this part. Sometimes when you combine two vectors, you just get a plain old number. Think about calculating the work done by a force. That's a dot product. But other times, combining two vectors gives you a brand new vector, pointing in a totally new direction. Think about the torque that makes something spin. That's a cross product. Knowing which one to use is the key. And that's a wrap on our review of Chapter 2. We've gone over the language, we've looked at the toolkit, and we've put it all together to see the big picture. Now it's time to think about what comes next. So I'll just leave you with this final thought. Everything we just covered, it's a set of tools. It's the foundation you're going to use to build your understanding of motion, forces, electricity, you name it. The real question is, now that you've got the toolkit, what are you going to build with it? Thanks for tuning in.